All right, so here are some examples that we're going to go through. These are just problems taken out of the book. The first one is page 556, actually, number 20. Will your flight get you to your destination on time? The U.S. Bureau of Transportation Statistics reported the percentage of flights that were late each month from 1995 to 2006. Here's a histogram along with some summary statistics. We can consider these data to be representative sample for all months, so there is no evidence of a time trend. Alright, so check the assumptions and conditions, find a 99% confidence interval, interpret this interval for a traveler planning to fly. Whatever. We're just going to do a 99% confidence interval. We don't need hypotheses because we're doing an interval. So let us look at our model. Okay. All right, our conditions, random, less than 10%, and those are for independence. And then sample size. This is the nearly normal. All right, so random. This is not a random sample. It's the times between 1995 and 2006. But they also tell us that we can consider it to be representative of all months. There's not evidence of a time trend, right? Like if it was more common for flights to be delayed in January or in September or whatever, that would be, these are not independent measurements. But it says there's not evidence of a time trend, so we can consider it to be representative. No, but yes. Is this less than 10% of all flights? I mean, if we're talking about the future, certainly it is. If we're talking about actually all flights that have been recorded so far, no, but like we're using this to try and figure out stuff in the future. Yes, because we're considering future flights. All right, now the nearly normal. All right, this was our histogram. Our sample size is 144, which is large. So all we're looking for is that it's not strongly skewed. This looks unimodal and symmetric-ish. Enough for me anyways. Even some reasonable skew would be allowed here. So we're good as far as that goes. Histogram. Unimodal and symmetric. All right. Now, let us take a look at our mechanics. Okay, so we're doing a one sample t interval. We'll use the x bar plus or minus our critical value times the sample standard deviation over square root of sample size. All right, we're given x bar is 20.0757. We're told n is 144, and s, the sample standard deviation, is 4.08837. Okay, so our interval will be x bar plus or minus. Okay, our critical value. This is where we need to do some work. Previously, we'd have drawn the normal model and done that stuff. And you can do that on your calculator too. But what might be nice is table T. This is, what is this? A76 table T. So a couple things going on here. We've got one tail probabilities, whatever. Let's look at the bottom. Confidence levels. All right. So we got 99% confidence. Running up and down the side, these are the degrees of freedom. Our sample size is 144, so our degrees of freedom is 143. That doesn't actually exist on here, but we have 140, which is close enough. We're looking for a 99% confidence interval. So our t-score is going to be 2.611. We could like try and interpolate between that and that, but whatever. 2.611. This is like, since this is larger, it's going to be a worst case scenario anyways. So we'll just go with that. 2.611. S is 4.08837 over square root of sample size. And that's our interval. You can turn that into numbers, whatever. All right. Now let's answer the question. So that's our model, or that's our mechanics, sorry. Now the conclusion. We are 99% confident that, what are we looking at again? The percentage of flights that were late each month. Okay. That between, oh, I guess we do actually need to do some calculation here. Sunny out now. Okay. So let's see now, 220, now let's get that, 2.611 times, let's see if I can zoom in so we can actually see this. All right, 2.611 times 4.08837 over 12. Okay, so this is our margin of error, 0.889. And we'll do, we'll just store that in X so that I can do 20.0757 plus X, 20.0757 minus X. Okay, so those are upper and lower bounds. All right. We are 99% confident that the true proportion, the true percent of flights that are late each month is between 19.18% and 20.97%. So a couple things. Our data was percents. So why are we doing T's? Well, it has to do with the fact that it is quantitative data, right? If I'm asking each month, how many of your flights were delayed? I'm not asking each month, are you a flight that was delayed? Like, this would be proportions if we were looking at each flight, but we're looking at each month, and each month is going to have a number, right? So our data looks like this: months, flights delayed. January 96 had 17% delayed. February 96 had 19.5% delayed. Right? This is quantitative. Categorical would be flight delayed. A 264. Yes. A 265. No. A 266. No. This would be categorical data. This is what we're dealing with. Each month is giving us a number. So this is still quantitative data. Oh, one more thing that I forgot to do before, and I found my fancy calculator now too. Show you the calculated way to do it. Alright, so we're under stat. That is a one sample t interval. So we're looking for t interval. It's just regular t interval. We do not have data. Data would be like if we had the actual values. We have summary statistics. So we had an X bar of 20.0757. We had a sample standard deviation of 4.08837. And we had a sample size of 144. And we wanted a 99% confidence interval. So we do that, and it does that, and it tells us everything we need to know. Yay.